In this video, we're going to talk about topic 10.10, alternating series error bound. And we're going to calculate the alternating series error bound in this lesson. So we're going to start by talking about the theorem of the alternating series remainder. So if a convergent alternating series satisfies the condition where my n plus 1 term is less than my a sub n term, meaning that it is decreasing, and the absolute value, then the absolute value of the remainder involved in approximating the sum s by s sub n is less than or equal to the first neglected term. So that means that s minus s sub n equals the absolute value of the remainder, which is less than or equal to the first neglected term. So in order for us to have an alternating series area remainder, it has to satisfy the conditions of an alternating series, meaning the limit as n approaches infinity of a sub n has to equal 0, and I have to have decreasing terms. So this first one here, we are supposed to approximate the sum of an alternating series. So approximate the sum of the following series by its first 6 terms. So the first thing, it's actually, they were nice enough and they made the terms out for us. If not, we would have been putting in 1 and then 2 and then 3 and then 4 and then 5 and then 6. So what I'm going to do is I'm going to actually multiply out those factorials. So I'd have 1 over 1. 2 factorial would be 2 times 1, which is 2. 3 factorial would be 3 times 2 times 1, which is 6. 4 factorial would be 4 times 3 times 2 times 1, which is 24. 5 factorial would be 5 times 4 times 3 times 2 times 1, which would be 120. And the signs are alternating here. Minus 6 factorial would be 6 times 5 times 4 times 3 times 2 times 1, which would be 720. And then when I put that in my calculator to calculate the decimal point, when I put it in the calculator, I get 91 over 144, which is equal to 0.63194.